In this video, we are going to discuss about the science that makes ice cream so creamy. Ever wondered why ice cream is so creamy, so smooth, and so irresistible? It's a question that has tantalized taste buds for generations. What makes it so different, so much more appealing than just a block of frozen milk, which can be cold and hard? That perfect melt-in-your-mouth texture isn't just luck, it's science. A delicate balance of ingredients and processes working in harmony. Today, we're uncovering the secrets, the hidden formulas, behind every perfect scoop. We'll explore the magic that transforms simple ingredients into frozen delight. Ice cream is a paradox. Solid, a frozen sculpture, yet melts smoothly, coating your tongue in creamy goodness. Cold, a refreshing chill, yet rich and soft, a luxurious indulgence. The journey from humble beginnings, just milk and sugar, to creamy dessert, a symphony of flavors and textures, is a microscopic battle of ingredients, a constant push and pull to achieve the perfect consistency. Understanding this process, the science behind the sweetness, will make you appreciate every single bite. It's more than just a treat, it's an experience. The creamiest ice creams are crafted, not just made, through careful steps, precise measurements, and unwavering attention to detail, each controlling the final texture, the difference between icy and divine. Next time you pick a pint, standing in that freezer aisle, remember, you're choosing a marvel of food science, a testament to human ingenuity and our love for all things delicious. Ready to discover the edible engineering, the secrets and techniques behind your favorite treat? Are you ready to become an ice cream connoisseur? Let's dig in. The adventure awaits. Making ice cream isn't just about following a recipe, it transforms you into a chemist, a culinary scientist in your own kitchen. You're not just a cook anymore, you're an alchemist, blending elements to create something truly special. At its heart, ice cream is a colloidal emulsion, a delicate dance of different substances. It's made of tiny fat droplets, microscopic spheres of richness. These droplets are suspended in water, creating a smooth, continuous phase. Add sugar, the sweetening agent that not only enhances flavor but also lowers the freezing point. And finally, air, the invisible ingredient that gives ice cream its light and airy texture. Your job as the ice cream architect, get these seemingly disparate ingredients to cooperate and form a harmonious blend. Remember, fat naturally resists water, they don't want to mix. Water, on the other hand, wants to freeze into a solid block of ice, which is not what we want in creamy ice cream. And air, ever the escape artist, constantly wants to escape the mixture, deflating your dreams of a light and fluffy dessert. Heating the mixture helps dissolve the sugar, creating a smoother base. Heating also unfolds proteins, allowing them to better emulsify the fats and water. Churning vigorously breaks up the large fat globules, dispersing them evenly throughout the mixture. Churning also breaks up any large ice crystals that form, ensuring a smooth and creamy texture, free from icy chunks. And crucially, churning incorporates air into the mixture, creating that characteristic light and airy texture we all love. Through this process, you're transforming a simple, sweet liquid into a semi-solid masterpiece of frozen delight. Every step, from heating to churning, is about carefully controlling this delicate balance of ingredients and processes. The result? A stable emulsion where fat and water coexist in perfect harmony, a beautiful foam, light and airy thanks to the incorporated air, and ultimately a creamy, smooth, and utterly irresistible treat. This is edible chemistry in action, a delicious demonstration of scientific principles. So, next time you churn a batch of your favorite flavor, remember, you're not just making dessert, you're orchestrating a molecular symphony, a delicate balance of science and flavor. Master the chemistry of ice cream, understand the interactions of its components, and you master the scoop itself. That's the secret, the scientific secret to creating perfect ice cream every single time. The enemy of creamy ice cream? Big ice crystals. The goal? Keep crystals microscopic for ultimate smoothness. Fast freezing is the secret. Slow freezing lets big crystals form, ruining texture. Commercial machines freeze quickly, often with liquid nitrogen. Homemakers do the same on a smaller scale. Churning constantly scrapes and mixes, breaking up crystals before they grow. If your ice cream is icy, it likely froze too slowly or started too warm. The result you want? Countless tiny crystals, so your tongue feels only creamy bliss. Master freezing speed and you master creaminess. It's simple in theory, but takes practice. Small crystals, big difference. Fat is the secret to rich, smooth ice cream. It coats ice crystals, keeping them small and slippery. Churning breaks fat into delicate chains, creating a creamy network. More fat means richer, denser, smoother. Fat also traps air, making ice cream lighter, easier to scoop. That's why premium brands taste so luxurious, they're packed with fat. Never underestimate the power of fat in your scoop. Sugar does more than just add a sweet flavor. It plays a crucial role in the overall texture and consistency of ice cream. It keeps ice cream soft and scoopable even at freezing temperatures by lowering the freezing point of the water content. This prevents the formation of large, icy crystals. Air, carefully whipped in during the churning process, gives ice cream its characteristic lightness and volume. Introduce too much air and the ice cream becomes overly airy, almost fluffy, lacking that satisfying density. Too little air, on the other hand, and the ice cream becomes unpleasantly dense and heavy. Premium ice creams typically have less air incorporated, resulting in a richer, denser, and more intensely flavored product. Precise temperature control is absolutely crucial throughout the entire ice cream making process. It's essential to thoroughly chill your base mixture before churning, and then freeze it as quickly as possible after churning to minimize ice crystal growth. Finally, harden the ice cream at very low temperatures to achieve the perfect consistency. After churning, ice cream needs to spend several hours in a deep freeze, allowing it to fully set and develop its ideal texture. Every single ingredient and every step in the process works in perfect harmony. The formation of tiny ice crystals, the creation of stable fat networks, the delicate balance of sugar for that perfect softness, the incorporation of air for that light and airy texture, and the cold precision required to bring it all together, the result of all this careful attention? A scoop of creamy, dreamy perfection. Now that you understand the science behind it all, are you ready to experiment and create your own frozen masterpiece in your own kitchen? Go ahead, open that freezer and taste the incredible results of your newfound knowledge. Your ice cream laboratory awaits your creative touch. So go on, enjoy that perfect scoop. If you liked it, tap that like and hit subscribe so you don't miss what's next.